So today we're doing a lesson for addition, which is targeted towards first grade. And we're going to use the Make 10 approach. And our word problem is John and Sam are sharing candy. If John has 15 candies and Sam has 18, how many do they have altogether? Okay, so let's set up our problem. If we have 15 plus 18, we're going to use 10 frames to work out this problem. So first we're going to start with 15, which is the number of candies that John has. So we're going to draw it into our 10 frames. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And when we look at this, we see that this entire 10 frame is full, so we have subitized this, because we recognize that this is 10. And so we're going to make 10 frame for the 18. So we're going to do the same thing for the number of candies that Sam has. Okay, we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to combine these. And we see that this 10 frame is not completely full, and neither is this 10 frame. So we're going to try and figure out a way to bring the leftovers from this one into this one to make it a full 10, to subitize this one as well. So since we see that we have 5 more that we need to fill in this one, we're just going to cross this entire line out and regroup those into this frame so that we have 3 full 10 frames with 3 remaining units. So that equals, so if we count 10, 20, 30, so we have 30 plus our individual units left over are 1, 2, 3. So that's 30 plus 3, which equals 33. And if we look back at our original problem, 5 plus 8 is 13. So we put the 3 in the tens place and carry our 1, or in the ones place and carry our 1 to our tens place. And 1, 2, 3 equals 33 total candies that John and Sam have. To add to this one, to our original 15, and added our 3 left over, which is 30 plus 3. And for some students, this is easier to see the tens than adding it in their head, 15 plus 18. Okay, so I'm going to demonstrate how to use a linear model for 4th grade to show elapsed time. And our word problem that we have for this one is Mary and Jill went and saw a movie. If the movie is 2 hours and 30 minutes long, and it starts at 6:30, what time will the movie be over? So we're going to start with drawing our model, which is a number line, or to show how much time it's taking. And the movie, in our problem, it says that the movie starts at 6:30. we're gonna mark that here, 6:30 p.m. Because we mark p.m. because we know that this is happening in the afternoon, not in the morning. And that is often a misconception with students, is they forget the difference between morning and afternoon. And that is important when you're working with elapsed time. And we're going to mark our number line in 30-minute increments. So, in the problem it says if the movie is 2 hours and 30 minutes long. So first we're going to start with marking off how many hours the movie takes. So if we start at 6:30 and we know that there's 30 minutes between 6:30 and 7 because we're using base 60 for time, which is also a misconception for students, is they think that this is different than base 10, base 10. So we're using base 60 since we're using time. So we make a jump from 6:30 to 7:30, and this marks 60 minutes, 1 hour. So we're going to do another jump since we have 2 hours. So we're going to go from 7:30 to 8:30. Which is another 60 minutes, which is another hour. So what we have left from our problem is just 30 more minutes. So we're going to make a jump half this size from 8:30 to 9. And that's our 30-minute jump. So we have 2 hours that we jumped, and then 30 minutes. So if the movie started at 6:30 p.m., and we jump an hour, another hour, and then 30 minutes, it's going to end at 9 p.m.